Ladies and gents, welcome back to Enginears, the podcast. Thanks for coming to join us. Today we've got Eric Landau, who's a chap at Cord, co-founder of Cord. And he's going to be talking to us a little bit about automating annotations in computer vision. Okay, so we're going to explore some of those topics and discuss some of the challenges and probably some of the growth opportunities that can occur in this space at the moment. So, Eric, do you want to give us a little bit of an intro into you, or say hello first? Do you want to give us a little bit of an intro into you, Cord, what you're building at the moment? Summarize that for us.
Sure. Yeah. And thanks for having me, Elliot. I think that was a pretty good intro. So we're Cord. We automate computer vision annotation. So if you're building some kind of AI or computer vision model, you need to have a lot of labeled training data. The kind of normal way that people do it is they send the data overseas to get annotated by literally factories filled with people that are just drawing boxes and polygons and classifying frames of things. So we thought that was a bit of an inefficient process. So we came up with some ways in which we can automate a lot of the process, bring down the human burden, and kind of pivot people's time from generating labels to actually reviewing labels and getting higher quality data sets. So that's what we've been doing so far.
Nice. Okay. We'll explore that we'll explore that in the next couple of moments. I learned this over probably the last month or so. So we're mid-September at the moment, but I've learned quite a lot more about machine learning algorithms, self-learning. So I'm keen to ask some of those questions because there is quite a lot of, let's just call it manual intervention in some of these processes. But give us a bit of a background into you and where you come from.
Yeah. So my academic background was in physics. So I studied physics at university. I started a PhD. I saw like the path of PhD was going to be long and arduous, and I had never done anything outside of physics. So I wanted to take a leave of absence to go try something in the real world, and that ended up becoming like a very, very long leave of absence. I went to go work in quantitative trading just to try it for a year. Yeah, I ended up doing it for almost a decade. It's what brought me to London. So I was working in trading equities. We were putting a bunch of models into productions, trade equities and ETFs and futures and things like that. After a while, I decided that I wanted to try something new, and I ran into my co-founder, Ulrich, who had just finished his master's in computer science from Imperial. He had worked on a project there visualizing massive scale image data sets. And he had this idea, and he just saw how arduous it was to label this data. And so that's where the seed of the idea came from, of using some of the techniques that he had thought of, some of the things that I had thought about while trading, and kind of putting it together to try to solve this problem.
Okay. How do you actually go from, and this will probably dive into Cord's core offering in the next
Yep.
couple of moments, but how do you actually go from manual labeling to automated labeling? Can you help us understand that part and what happens in between?
Yeah, so there's kind of a cocktail of methods that you can use, some heuristic based, some based on the business logic of the particular problem at hand. But the main method that we use, and something that has been quite successful across a lot of different domains, is this concept that we came up with called micromodels.
Okay.
So these are annotation-specific models that are verticalized for a particular task or particular piece of data. So what we realized was that you could try to automate the entire labeling problem with one singular model, fit a bunch of data, and continuously like fit and retrain that model. Or you could look at it another way and break down the problem into much smaller parts, decompose it into these very small models that are focused very specifically on one part of the problem. So you can have one model that's focused on one video, for instance, or on detecting one type of object within your labeling structure. And by doing it that way, you can very quickly, with very few manual labels, start generating these pieces of automation. So within a few minutes, you can start training one of these micromodels on the platform, run it, and then get into active learning loops with each micro model. And what we do at the end is we ensemble all these micro models together to cover your entire kind of labeling distribution. So the normal flow looks like, you put some data onto the platform, completely, raw. There's no labels. You spend 1 or 2 minutes annotating a few examples. You very quickly train the micro model, and then you start using the micro model to generate more labels, correct them, improve the micro model, et cetera, et cetera. And
Okay.
that flow has worked quite successfully in a lot of domains.
My knowledge is quite shallow. Okay, I've been quite upfront about that pre-podcast. Surely this has to be revolutionary from some of the companies and people that I've been speaking to, and the manual labeling to actually help your algorithms self-learn. There's been so much time and energy, and there's so many variables that you have to label as well. Surely you have to be doing something that is revolutionary in your space, or at least you believe so, right?
Yeah, I mean, I don't know if like revolutionary
Fine.
overstates it, but we do have a different approach. The thing is that right now, basically everything that's coming out in computer vision AI is revolutionary to some degree, just because the
Okay.
space
Yeah.
is so new and none of the best practices have been established yet. We're in the very, very early days of this stuff. So, there's a lot of like easy money of just doing this kind of human wage arbitrage, which a lot of these companies are doing, of just
Yeah.
sending data overseas, getting it labeled by people, and sending it back. And a
Yeah.
lot of companies just kind of followed that easy money trajectory. And so there was maybe less incentive for them to try to automate these processes. So I don't know if it's something that was kind of technically blind to them, or if it just wasn't in the best interest of the business to start thinking about these things in this way. But again, it's still like super early, and we're constantly improving our methods, and we're refining, and we don't know what the final answer to this problem will be. It could be that label data will not be the biggest problem in 3-4 years because unsupervised learning techniques take over, for instance. So I think there's this kind of need to just be humble with what you're creating in the space,
Yeah.
because you'll always be upended in a year or a couple months or so.
Okay. You've probably given us quite a lot of context anyway on what Cord do or what you're all building. But can you tell us a little bit about life at Cord at the moment, and what that looks like and what you're working on?
Yeah, so it's pretty exciting because we're growing quite rapidly
Yeah.
from the customer side. So we're having new customers come in that have a bunch of like really interesting use cases, applications of computer vision that I would have never have guessed. So things that are quite
Okay.
surprising to me. And with that comes a lot of feature requests and a lot of kind of thought of like, how do you optimize the platform? How do you improve methods? How do you add more intelligence to fit this kind of new use case? How do you add more techniques that we see a lot of our customers are doing redundantly across themselves?
Yeah.
So from our perspective, someone that's working with us, we're kind of showing, okay, here's what's going on on the business side of things. Here are the sets of of priorities and features that will help this client and this client and this client. And then
Yeah.
we're kind of giving it to the engineering team to figure out, all right, how do you actually implement this into something that we can then ship back and create value for them? So we're in a very agile kind of environment. We're
Yeah.
constantly interacting with the clients and figuring out ways of improving the platform and doing it very
Nice.
dynamically at a very kind of fast pace.
You're self-learning yourself then, which I quite like, or Cord is as a business as you're growing, like you say. Where do you think you guys and girls can be in the next 1-2 years?
I wouldn't have expected that we would get to where we are now so quickly. So it's very hard to kind of extrapolate the
Let's not
future and
project
imagine.
2 years then.
Yeah. So what we want to be, essentially, what we're trying to build is not just an annotation platform, but really a training data platform.
Yeah.
So
Okay.
we want to be the infrastructure for training data, and there's a whole host of problems that are associated with getting a training data pipeline working. The annotation piece is the biggest bottleneck for teams now to
Yeah.
build these applications. And so, starting with automating it will be like a big hook to start getting all of their training data tools and infrastructure through us. So we have kind of a very wide vision of going beyond just labeling and really being like a data centric
Okay.
AI platform, and servicing like all types of computer vision use cases through that.
Nice. Okay. If we just begin to roll back some of those conversations away from the data training platforms and go back to um, some of that annotation piece, help us understand, which we've spoken about offline as well. Help us understand some of those challenges around image and video annotation, because I think that they're quite interesting to explore.
Video, for instance, has a bunch of challenges that naturally come with it. It's a very dense data type. It's very heavy. It takes a lot of space.
Okay.
A video, 30 frames per second. Every second you have 30 images associated with just that moment. So you often don't need to annotate every single frame of it. So if you're a company, let's say a gastroenterology company
Yep.
that's trying to build an AI model for detecting polyps or whatever, and you're given a bunch of video, do you go and annotate every single polyp example for every single frame of the video, or do you have to figure out some way of subsampling the video, for instance, such that the performance of the model won't degrade, but you don't have to throw as much data through the process and like incur a lot of compute time. So there's the idea of kind of managing all of these like big data
Yep.
structures, just from a kind of piping perspective. There's the idea of figuring out how do you intelligently subsample this stuff so that you can get it lighter and you don't have to go through the entire piece of data. There's a bunch of like just more nuanced technical issues related to videos. So syncing frames with timestamps, for instance, getting corrupt frames, kind of moving moving video data back and forth. Those are kind of in the weeds, but it's like inherently just very tricky thing to manage just because of how dense it is. Images, it's a slightly different. It's a different set of problems
Yep.
because images can be free floating; they don't necessarily have to be stacked together. But it has a kind of a same. There's a same kind of flavor of problem in that if you have a bunch of images from a distribution, do you label everything? Do you label a subsample of it? How do you effectively manage it? How do you make sure that your model is doing well across all the images?
Yep.
It's quite tricky from a lot of these AI teams.
What have you learned about some of those differences? You've spoken about a little bit earlier in the podcast. You've learned a lot about some of the different use cases in companies using computer vision. Help me understand a little bit about what you're learning about both and how that evolves.
Yeah, so I'm learning that there is no limit to the type of use cases for this technology. And when I say like some very surprising use cases, I don't know if I can share all of them, but
Okay.
there are some like super, very, very surprising use cases. So one company that is, like I think a well-known Irish company, they are quite a big business. They just do facial recognition for cows, and that's
Okay.
like quite a big business just doing facial recognition for cows. Not something I would have ever anticipated as being a problem, but one of the things where once you hear about it, you're like, oh, okay, yeah, that makes sense. But I would have never imagined it from kind of a first principles perspective. So what I'm learning really is that anything that a human can kind of perceive from like a visual perspective, sometimes things that we can't perceive in kind of more rare computer vision modalities, you can find a use case for that can do something interesting in the real world. And again, like there's just a bunch of examples kind of floating around my mind, but we have to like keep some of these things secret. But it's quite exciting to kind of learn about this new stuff.
Nice. Give us one or two examples.
Okay, so yeah, the things I can say publicly. Okay, so an example is because it's coming out in a paper, something that we worked with the Stanford Department of Medicine. It was a nephrology project to detect these substructures in mouse cells, right? And it's kind of this esoteric problem, but we realized, and the way that they were doing it in the lab was they were doing it extremely manually. It was doing it over 3 different pieces of software. They would kind of find the cells, like some lab technician would find the cell and then move that data over to another piece of software where they could find the volume of the substructure in the cell, which would then go to another piece of software for analysis. And we realized, when we heard the use case, oh, you can just automate the entire thing with our platform. So that's what we did. We just showed them, oh yeah, just do this, this, and this. And then like your analysis is just done, and you can use these micro models and some other kind of automation pieces to just get the final result without spending days of some poor postdoc's time to do it. You could just do it through kind of an automated fashion. So
They
that's
shocked.
Yeah. They were. I think they were quite happy. They were like, oh yeah, this saves a bunch of time. They're quite thankful about the process. So that's like a public use case I can share. There's so one kind of more like esoteric use case is like a thing of just interacting with buttons and things through websites. And you would think that there was kind of a programmatic way of doing that, but there are some companies that are actually doing this through vision. So having models to detect things that are on a screen and then figuring out like what you should do with those things on the screen in places where you don't have access to the actual the code to access what is actually available on the screen. You can just put a camera on it. That's an interesting use case that I think is a relatively public one as well. But there's a bunch of these things. It's pretty crazy.
As I think about it, and this is probably slightly off piste, but I use the word revolutionary. Fine. Maybe you're not revolutionary, okay? But as I listen to you and some of the businesses that you're working with, clearly there's an appetite for the simplicity, the effectiveness, the speed for Chord.
Yeah.
I don't necessarily want to put you on the spot, but what do you think are your limitations at the moment in terms of just being let's just say, a service platform for everyone in CV right now? What are those limiters for you?
To be honest, like the limits that we're experiencing now are just headcount, getting more people on board, because we're super bandwidth constrained on the people that we have in the company. So that is really our main limit now. Cool. In terms of technologically, because we were thinking about these things as micro models rather than like kind of bigger, broader models, it actually is surprising that it works quite effectively across a bunch of different domains, because you're really getting the problem to be like the simplest nugget that it can be, and then throwing a model at that simple nugget. So, at the simplest basis, something like an autonomous vehicle problem doesn't look so much different than a microscopy problem, or doesn't look so much different from robotic process automation, or agriculture or satellite imaging. And so decomposing it has been like quite effective in kind of transcending these vertical use case bounds. Of course, there's other kinds of limitations that we're facing just in terms of scaling and infrastructure and figuring out how to do all the ML ops correctly, and getting the right kind of compute services up and running and things like that. But it's not on the deficiency of like the ML side. It's more of all of the operations and infrastructure that we're kind of feeling the most constraint with now.
I was going to say, from a scale, infrastructure, and compute perspective, that has got to be astronomical with just the sheer volumes of data that you're operating with at such speed.
We have a bunch of data on the platform, a lot of kind of throughput of data. And we're training a bunch of models. Luckily, this is much easier than it would have been, 10 years ago. Now that you have all these cloud providers that you can kind of easily scale up with, but the ML side of this stuff is still extremely tricky. Managing GPUs extremely tricky. best practices again have not been established here, and so we have to we have to do things sometimes the hard way. I think in 5-10 years we'll be looking back at this kind of how we're looking back at the compute problems that people were having 10 years ago, and there will
Yeah.
be equivalent of a AWS or GCP for all of these kind of ML ops problems that would have
Yeah.
been just like now a click of the button. I think we'll be part of that solution, but we're definitely feeling the pain of not having that now.
Okay. What are some of the tools and tech that are quite prominent at Cord? Give us an understanding of your environment, tech environment.
Yeah. So from like our tech stack, I think aside from all of the ML things is pretty vanilla. Front
Yeah.
end React Redux. We use Tornado web server on the back end, which is kind of like it's in between like Django and Flask, and
Yeah.
um, we Postgres database. We're using AWS and GCP. All that stuff I think is like fairly vanilla from the tech perspective. On the
Yeah.
ML side, it's there's just we use basically every library. So
Okay.
we're throwing a bunch of stuff at the problem, and so yeah, like if you can think of like some kind of ML or AI library, we're probably using in some capacity.
All right, nice, cool. What do you think we need to know about micro models? Because it's popped up a couple of times. You gave us a really good intro into it really early on in this pod, and we've touched on it just over a couple of moments there, where you're probably able to diversify some of those micro models across different problems and use cases. So, as an audience, what do we really need to know about micro models? Do you feel?
That and there's like some controversy over this, but that overfitting does not necessarily have to be a bad thing, because like essentially the idea behind micro models, like you're fitting to a very narrow space. There's like some debate over like the parlance here, but you're kind of overfitting to a very narrow part of your data distribution, or a very kind of narrow set of tasks, and that's not recommended kind of practice in AI. So
Yeah.
people shy away from it. But because we just kind of are using these models as a tool, we're happy to do it because we just see that it makes the process actually more efficient. So yeah, to not be so afraid about this idea of kind of overfitting for this purpose,
Okay.
in that we're not using this as a robust kind of downstream model that you're using on out of sample data where a human is not involved at all. So I think that's like one concept that I think people can get familiar with in terms of how we're approaching this stuff. Yeah, and just the second is that they work surprisingly well across a lot of different domains. I think that's something that we weren't confident in the beginning, but it just empirically has worked across a bunch of different things. So yeah, those are kind of two ideas to plant in about micro models. But
Okay.
happy to like go into any like specifics around that.
Yeah, I was going to ask how tough is it to get the accuracy right for micro
Yes.
models on two different problems? Because I think that's quite an interesting concept. Let's use the mouse cells and maybe recognition in the cow's face. That model specifically might not be used for the two of the same things, but how do you get that accuracy right?
Yes, so that's a great point, and that's kind of like another very big aspect about this methodology is that we do not think of accuracy in the same way that normal data scientists think of accuracy.
Okay.
Accuracy here actually doesn't really matter for us. What matters is efficiency. So it's throughput of generating labels of sufficient quality, and sufficient
Okay.
quality means that it's been reviewed by a person at the end of the day. So if you have a model that's even 50% accurate, but you can speed up the labeling process by 2x or 3x, that's a
Okay.
win for us. Even though the
Right.
model is not going to be used, it's not going to be used in another context besides this labeling procedure. It still has been super useful in generating labels at less cost and with more scale. So we have like a very different way of kind of thinking about accuracy, and
Ah.
because we're okay with overfitting the stuff, we're also okay with the models not doing well from an accuracy standpoint and out of distribution data. They're not supposed to, and you wouldn't expect them to. So yeah, kind of this kind of other perspective of the way that you think about accuracy of models is kind of something that we've developed over time.
That's a really good way to actually understand Chord as a business. I think if you look at traditional models, from what I understand, the accuracy has always been around, let's just say, a 90% rate of, let's say, success on this is a football, for example, or every time you see this shape in a picture, it is a football. So I think how you've just described that is a really good way for me to understand Chord. I feel now.
Yeah, it's think of models in a different way. That's kind of, we're using models we're ML for ML, so
Yeah,
you have to
sure.
think about the first part of ML differently, because otherwise you say, well, why can't the second part of ML do the first part? So yeah, we just have a different perspective on these problems. And,
Yep.
our goal is to generate training data as fast and as cheaply as possible, as scalably as possible. What you
Yep.
do with that training data is a completely different process, and should go through all like the best practices of data science, AI. Don't overfit kids, so do the right thing with your data. But for us, we have a different way of doing it.
Okay. Again, slightly off piece. Talk to us about recent funding, because this will correlate back to scaling, growing, operations, etc. So, talk to us about recent funding and what this means for you and the team.
Yeah, so we came out of Y Combinator at the beginning of this year. We raised a seed round after that. We raised like I think a fairly sizable seed round for Europe at least,
Yeah,
and have just been growing the team since then. Again, the business itself is growing quite rapidly,
yeah.
and we I think we've been okay on the funding side. So
Yeah.
yeah, we're pretty excited about where we are now, as like in the kind of place of the business. But we raised a $4.5 million round that
That's pretty impressive.
I think I mean, the environment is very favorable. It's even more favorable now than when we raised our original seed round. So yeah, it's kind of being at the right place at the right time.
What do you mean environment? Do you mean state of the world at the moment in terms of investment and VC?
Yes, the VC
Okay.
environment is quite favorable now.
Okay. What was it like coming out of Y Combinator? If you can talk about some of those details.
Yeah, no, Y Combinator was great. We got a lot out of it. It was remote,
Yeah.
but we actually did go to California to spend it there, because we thought we would be clever, and we would be in the same time zone as all these other people in Y Combinator. But
Smart.
it turns out most of our customers were in Europe, so we ended up being up very late or very early, and it was a terrible decision for us to go to California. But it was still nice to enjoy the weather. But what YC does is they really kind of put this framework of accountability around you, to actually focus on growth, to really kind of building the business, to not sit around and kind of tinker on the tech, and just kind of, it's easy to get lost in the weeds of engineering because that's where your natural inclination is to go. But
Yeah.
to actually take what you've built and put it out into the real world and see
Yeah.
people actually gaining value from it and growing from that. So that accountability and the network and the mentorship was all
Yeah.
really, really good. And then there's the fundraising piece, which Y Combinator is kind of like is this fundraising factory that's very
Yeah.
efficient, effective now at the stuff. So we got a lot out of all those different aspects of the program. Super glad that we did it.
Good for you. Honestly, really good for you. Talk to us a little bit about scaling the team and what that's going to look like over the next 12 months or so.
It's been kind of a slow, deliberate process. We've been kind of very careful with the first people that we bring on board.
Yeah.
Coming out of Y Combinator, coming out of a seed round, because we know that the first person that you get will bring the next 30 people that you get, right?
Yeah.
So there's this huge leverage effect between the quality of the initial hires that you get and the quality of the entire organization over time. So we were quite choosy in the beginning, and now we've kind of built out a core team. And once you have a core team, then the process accelerates a little bit because now you can get other people to help you interview for the next batch of people. But yeah, we're looking to kind of expand the engineering team. There's plenty of room on the ML engineering side. Finding good front end people is always a tough one. I think that's something a lot of companies are struggling with now. That's definitely something that we would love to get, experienced front end people on board. And then kind of hiring on the after getting the engineering kind of team in place, is it would be hiring on the kind of sales and marketing side, which we're still yet to do.
Good. Okay. For everyone listening, there's going to be some links below where you can reach out to Eric and the team and come and learn a little bit more about what they're doing if you haven't already, and you can reach out to the guys directly. Have you got a message for people about Chord and probably how you would describe culture, collaboration?
Yeah. So, culture is just the values that you probably have personally and that you want reflected in the organization. The values that, my co-founder and I really put a lot of weight into are integrity, transparency. We want to be, have a lean environment. We want to have growth mentality. So we're both from finance, and in finance, if you make a mistake on a trading desk, you can't hide it to yourself. You have to be very quick to admit that you made a mistake. And there's this kind of this idea of like transparency, and you have to have a lot of integrity to be able to kind of manage within that environment. So I think a lot of those same kind of cultural values probably have flown to Chord. But yeah, we also want people that are willing to learn and to grow, because this space, again, is so new and so young, and there's so much that we don't know about the technology yet and is yet to be discovered, that we can't just have people kind of sitting down in stasis and in equilibrium, kind of working on a problem that might not be relevant in 6 months or a year. They have to really kind of have this idea that, all right, well, stuff is going to change, and I'm going to change with it, but I'm going to get stronger, and I'm going to learn a lot along the way. So I think all those things are what we Ulrich and I personally value, and I think it's what our initial team also values when we're kind of bringing them on board.
Ladies and gents, if you're in the engineering sphere, I think these guys and girls are definitely a team to look out for, a team to explore. If you're interested in ML, CV, and I think what's next in this space, I feel, again, fairly shallow opinion, but I feel from what I've heard and seen so far over the last 1-2 years, these guys are at the forefront of the industry with some of what they're doing. So, Eric, I just want to say a big thanks. A big thanks for chatting to us, giving us 35 minutes of some really good content on you guys and girls, what a micro model is, and some of what you're building. So a massive thanks, and honestly, really best of luck.
Yeah, no, thanks so much for having me on. I really enjoyed the conversation. And yeah, thanks for giving us the opportunity to speak to your platform and your audience. And yeah, we look forward to kind of staying in touch and seeing how this stuff plays out.
Pleasure. Absolute pleasure. And for everyone listening, if we can give likes, shares, recommendations, subscribes, and all those fun social things, I think that'll go a massive long way for Eric, Ulrich, team at Chord. Thanks, guys and girls. Bye for now. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found at Enginears.io. It's no underscore. We've also got a website, which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.